transformation. Fourth type is reflection. Okay, fourth type is reflection. But in reflection there are the 5 types. First one is reflection about the x-axis. Second one is reflection about y-axis. Third one is reflection about the origin. Fourth one is reflection about the line y is equal to x. And fifth one is reflection about the line y is equal to minus x. Okay, we go for one by one. First one is reflection about the x-axis. In diagram, we see that the reflection about the x-axis. The line P1, P2 is reflected about the x-axis, means the horizontal axis of P1 dash, P2 dash. Reflection about the x-axis. We already know if it is reflected about the x-axis, then y coordinates become a negative, means y is negative. Then new coordinates for finding the new coordinates, the reflection matrix is mx is only y coordinate is negative 0 1. It's a 1 0 0 minus 1. Okay, reflection about the x-axis, y coordinate is only negative. X coordinates is become same, y coordinates is negative. Then next one, reflection about the y-axis. Diagram shows that reflection about the y-axis. Similarly, reflection about the x-axis. Only here reflection about the y-axis means x become a negative. Then reflection about the y-axis, y, x become negative. It means minus 1 0 0 1. Reflection about the y-axis. Only x become negative value. Other one is same. Third part is reflection about the origin. In diagram, we see that reflection about the origin. Point P xy is reflected about the origin, and get the point P dash is a x1 y1. Then x and y both are negative. X and y both are negative. In case of reflection about the origin, x and y both are in negative. Then reflection about the origin, MO is become minus 1 0 0 then minus 1. It's a transformation matrix for reflection about origin. Okay, for reflection about line y is equal to x. In diagram shows that one line P1 P2 is reflected about line x is equal to y or y is equal to x. This line reflected about the line y is equal to x or x is equal to y. Then if y is equal to x, the new coordinates of x dash become y and y dash become x, because x is equal to y or line is y is equal to x. Hence, if line is reflected about the line, reflection about the line y is equal to x, the new coordinates for finding the new coordinates, okay, matrices is m y is equal to x is equal to y x or y is equal to x is equal to 0 1 1 0. Okay, only reflection, but x dash become y, y dash become x. Therefore here first is 0 then 1 then 0, means you can interchange the value of x and y because of line reflected about the line y is equal to x. Line P1, P2 is reflected about the line y is equal to x. Therefore, new matrices is M y axis 0, 1, 1, 0. Then next is reflection about the line y is equal to minus x. Reflection about the line y is equal to minus x. Again, in diagram, they will show that y is equal to minus x line. Reflection about the y is equal to minus x. Then, for y is equal to minus x, for y is equal to minus x dash become minus y and y dash becomes minus x. Okay? Y is equal to minus x, then x dash becomes minus y dash becomes minus x. Negative sign is applied with the interchange of x and y. Hence, new for finding the new coordinates, matrices will be M y is equal to minus x is similarly same but in negative value 0, minus 1, 0. Okay, this is the reflection. 1, 2, 3, 4, 5 types of reflection. Okay? Go for next. Okay, again in shear there are two types of shear. First one is x direction, second y direction. Okay, first one is x direction shearing, second one is y direction shearing. In figure here in x direction shearing you see that it's a original and next one is after shearing. Original before shear, new is after shear. The point, it's a rectangular. The point is PXY is after shear is here become a P dash is a X dash Y dash, means before shearing, after shearing. If yes, HX is a shearing in X direction. In X direction shearing. Okay. For this finding the value of new coordinates, only X direction shearing, it's a P dash is X dash Y dash. Okay. X dash Y dash is for shearing in X direction 1 SH x 0 1 into the x 1 into xy. Therefore, shearing in x direction, it's a matrices is 1 SHX 0 1. It's a matrix for sharing in x direction. Okay, sharing in x direction. Similarly, if it is a sharing in y direction, then yes, HY is y direction sharing. Okay, sharing in y direction. Is it okay? Then matrix for the finding the sharing in y direction is matrix for finding sharing in y direction is SHY is equal to the 1 0 SHY and 1. It is a matrix for finding the new coordinates if sharing in y direction. It is if sharing in x direction. Okay, these are the 5 types of transformation, and we have to see that what are the transformation matrices about the all 5 types of transformation. Okay, go for next. Next in transformation is concatenated or composite transformation. concatenated or composite transformation. Okay, concatenated or composite transformation means you can transform one model in multiple transformation, means more than two or more than two transformation, means you can rotate the geometry and then reflected it about the x-axis, about the y-axis, and anything, or you can shift it in a direction then rotate it, means it is a combination of two or more transformation. It's called composite transformation or concatenated transformation. Okay, means you can mix up with two or more transformation. It may be rotation, it may be scaling, it may be reflection, it may be translation. Okay, for this term we have take one example. Okay, consider point P xy. Okay, P's coordinate is x and y, is to be transformed to the new position. Transform to the new position. P dash is a x dash, y dash. With by first it is a rotation. First it is a rotated. Okay. Second, scaling. Second one is scaling. Okay. First one is rotation. Second one is scaling. Okay. Then how you can calculate the new coordinates of x dash, y dash. New coordinate system of x dash, y dash means for point P dash, it's a first one is the rotation, second one is scaling. Then you can take in multiplication, you can take in reverse direction. In second one is scaling, take a scaling matrices, then take a rotation matrices, and then last one is original point coordinates P. Means second is scaling, first one is rotation, but you can take here first is rotation, first one is scaling, second is rotation, then original point P. Okay, then it's become CT, composite transformation, and P. This is called as a matrix for composite transformation or concatenated transformation. CT is a new matrix and it is called as composite transformation or concatenated transformation. Concatenated transformation. Okay, CT. Okay, if you have to find out the CT matrices, CT is scaling, then rotation matrix. You know the scaling matrices is Sx 0 0 Sy. Okay, and in rotation matrices cos theta minus sin theta, then cos theta is the rotation matrices. Then CT becomes Sx cos theta. Okay, Sx cos theta minus Sx sin theta, Sy sin theta, Sy cos theta. It's a new matrix, composite matrix CT. Okay, this is called as